So let's discuss about supercapacitors, which is also known as electrochemical capacitor, which is an advanced energy storage device that bridges the gap between conventional capacitors and batteries. Unlike batteries, it stores energy through electrostatic charge accumulation rather than chemical reactions. To understand about supercapacitors, we first look upon their cell diagram, which consists of positive and negative porous electrode, and there is a permeable separator in between. And we first look upon the Nernst equation, which is E cell is equal to E0 minus RT by NF log Q. This equation crucial in predicting how the electrochemical potential develops at the electrode-electrolyte interface. If it also helps in understanding voltage variation and electrochemical stability of the capacitors. Next, we apply Coulom's law, which relates the molar conductivity of electrolytes to their ionic concentration and mobility. In supercapacitors, this law helps us to understand and optimize ionic conductivity, which is a key factor in achieving quick charge discharge performance. If there is a high ionic conductivity, there will be a faster ion movement, which results in better performance. Talking about the cell operation, there are several factors. First, we are discussing about the potential. Usually, supercapacitors operates typically between 2.5 to 3 volt for commercial devices. And talking about the conditions, the several conditions such as temperature, humidity affects the performance of the supercapacitors. And talking about the efficiency, the overall round trip efficiency is around 85 to 98%, which offers much fast charging. And also the equations given here determines the cell operations. Talking about the double layer formation, the ions in the electrolyte solution are attached to the electrode surface, creating a compact layer IHP and a diffuse layer OHP. Here we have one graph which shows the potential versus distance from electrode, where the potential shows off sharply as move from the electrode. Next, talking about the design concentration, for a optical performance, the mass transfer, which is the movement of ions to and from the electrode surface, must be fast and efficient, and the catalyst must be employed in certain type of hybrid capacitors, which also facilitate the redox behavior or which also enhances the surface activity. So these are the equations required for making or designing a supercapacitors. Scaling up from lab to industry, which involves a translating scientific principles into scalable designs. So this includes setting performance targets such as energy and power densities, optimizing the electrode materials for cost and sustainability, and adapting to industrial scale roll-to-roll manufacturing techniques. Talking about learning to cell design, the concentration, activity, and rotating disk electrode, that is RD, concepts are applicable to supercapacitor system, especially when designing and optimizing high performance cells. At last, we are going to understand how the electrochemical engineering plays an important role in understanding about supercapacitors. So it discusses about various factors such as electrode design and materials. By understanding electrode design, we will get an idea how the surface area, porosity, and material choice will affect charge storage capacity. It also understands how the charge transfer mechanism is going to happen, and also the electrolyte behavior, and talking about the modeling and simulation, which actually predicts the performance by using the electrochemical models for design improvement. So by understanding principles from electrochemical engineering, we can develop a supercapacitor, which is actually essential in today's technology driven world. Thank you.